Hi and welcome to your first official lesson. For this lesson, I do want you to practice note taking. The things that we're going to be talking about are going to be important all year long, and short term, it's going to help you with the project that we have coming up this term. So I want you to take really good notes, and I will show you exactly how I want you to take notes, and it starts by looking at your screen. You can see I've got this page and we have the date in the corner. Even if you're watching this on a different date, write the current date. Whatever today is, you write that down. For me, it's September 9th, so I've got that written in the corner. We're going to title our notes, and the title of this note is How Good Mathematicians Do Math. Below that, the subtitle is the 8 Standards for Mathematical Practice. So I'm going to have you write that down so that you remember on this page what these notes are all about. If at any point in any of these videos I go a little bit too fast, remember that you can always pause. If you need extra time to write something down, you can go ahead and pause and write it down. I'm not always going to go slow enough that you'll have a chance to write it down, so make sure that that pause button is your friend. Moving on, now that we have this written down, to get us started, I want to use a thinking map. Specifically, I want to use the circle map because I want to talk about what good mathematicians do. Think about a good mathematician in your life. Maybe it's your parent who always helps you with homework. Maybe it's your aunt who tutors you, or your older sibling who is in high school and can help you with your math. Maybe you're thinking of a famous mathematician. Maybe you're thinking of yourself when you aced that test. Think about the good mathematicians in your life. What do those good mathematicians do? What are the qualities, the characteristics, the behaviors, the habits? What do those good mathematicians do? I want you to take a second and fill out your circle map with that in mind. What are the qualities and characteristics and behaviors of a good mathematician? This should take you about 2 minutes. Go ahead and pause the video now. Welcome back. Now, instead of me taking the time to write all of them out, I'm going to show you an example of the circle map that my last class came up with. They had all of these wonderful ideas. They said that good mathematicians show their work. Good mathematicians ask questions. They're hardworking. They do their homework. They show multiple ways of doing something. They don't ever give up. They listen to others. They learn from their mistake. They study. They explain things. They admit when they're wrong. There's so many good characteristics. So if you have any of these that you like and you want to add it to your own circle map, please do so. The more that we have here, the better. The great thing about all of these qualities and characteristics are, remember, these are what good mathematicians do. So if you want to be a good mathematician, you have to do these things. And we have these 8 standards for mathematical practice that take care of all of these things. They're kind of some guidelines that remind us what good mathematicians do, so that when we get stuck or we're feeling like we can't do it, we look at those 8 standards and we remind ourselves that we can also be good mathematicians. The rest of the notes will follow a specific format as we are trying to become good mathematicians and learning about all 8 of the math practices. We're going to cover one new math practice in each of these video lessons. They will all follow this specific format, where we first start by writing down the math practice number. We will write down exactly what the math practice is. Then we'll talk about any words that we don't know, clarify things that we don't understand so that we can really truly know what that math practice is all about. After that, then you have the job of writing down what it means, putting it in your own words. Sometimes the math practices use a little bit bigger words or phrases that you're not familiar with, but you'll understand them and want to rewrite them in words that do make sense to you. After that, we will have an activity or an example that demonstrates that math practice. And finally, we'll finish up with reflection. What do you need to do to follow that math practice? What is a goal that you can set so that you can become a good mathematician using that math practice? So this is the format of the notes that we're going to take, and I'll model it throughout this video and the next. Let's start with math practice 1. Math practice 1, you're going to see I'm writing right below that circle map. Here's the circle map, and we're going to write below it Math Practice 1, which is make sense of problems and persevere in solving them. Remember, if at any point you need to pause the video to make sure you have enough time to write it down, please do that. I do want your notes to look the same as mine. Math Practice 1, make sense of problems and persevere in solving them. There might be some words in there that you're not familiar with, words that you don't fully understand. One of those words is probably persevere. What does persevere mean? You might remember from the disclosure statement, we talked about one of the goals of this class is not just teaching you math, but also teaching you perseverance. It's a valuable life skill. So what does it mean? Perseverance means you try. You keep trying, even when it's hard. I'm writing this down right below the word persevere, as you should write down in your own notes too, so that later on when you forget, you can always come back and remind yourself what persevere means. Keep trying even when it's hard. It also means you're going to keep working even if it takes a long time. Perseverance is like the little engine that could. He kept on trying and trying and trying, even when it was hard. He didn't stop because it was hard. He stopped because he was done. And that's what perseverance is. Don't ever stop because you're tired. Stop because you're done. The next one we want to talk about is make sense of problems. When we make sense of problems, we're trying to understand them. There are a lot of strategies for making sense of problems, but the main gist of it is however you do it, you try to understand. We can't solve a problem if we don't know what it's asking. Now that we've clarified things that you don't know, I'm hoping that pretty soon you're able to write it in your own words. That's the next step. We talked about those words that you don't understand, so our next step is, this means ... but instead of ... you're going to write it in your own words. Maybe you don't use the word perseverance in your own life, but maybe instead you can use words like trying even when it's hard, or trying even if it takes a long time. So write this in your own words, and I'm not going to talk about any more what you need to write here because that needs to be your own words. Your first assignment after this video is to write in your own words in Canvas. Share it with me so that I know what you think this means. After you're done writing what this means to you, we're going to go over an example. So, in your own words, and below that write, for example. And here's your example. It's quite a big one. Don't write any of this down yet. I'll tell you when it's time to write again. Example for Math Practice 1. Jared wants to paint his room. The dimensions of the room are 12 feet by 15 feet, and the walls are 9 feet tall. There are 2 windows, each with dimensions 6 feet by 5 feet. There are 2 doors, each with dimensions 30 inches by 6 feet. If a gallon of paint covers about 350 square feet, how many gallons of paint will he need to put 2 coats of paint on the wall? Man, that was a lot of information. I'm sure you're worn out just from listening to me read it. I am from having to read it. So where do we even get started? That's so much, it's so overwhelming. And that is a prime example of perseverance. We don't stop because there was too much information. We stop, we take the time to think, and we push on through. So what does it mean to persevere in this problem? Well, first of all, it means don't get overwhelmed. It means this is a multi-step problem, so just take it step by step. And keep on going. Even after you've completed a step, finish and move on to the next step. Finish that one and keep going. Now the challenge is, how do we make sense of this? One of the best ways is first, reread it. As you reread it, you might want to pay attention to certain pieces of information, but it's still hard to know what pieces of information to pay attention to. So, other strategies that I recommend, visualize it. Have you ever painted a room? Are you in a room right now? What would it be like if you had to paint that room? Does that room have windows and doors? Is one coat of paint going to be enough? Those are all things to consider as we visualize being in Jared's shoes. So visualize the problem. Another great suggestion I have for this is draw it out. Draw a picture. And if you're not sure what picture to draw, start by maybe acting it out. Understand what's really happening. Forget about the numbers and just read it, thinking of it like a story. Act it out is a great way to really understand what's happening. So, how do we make sense of these problems? Try any of those strategies. Now, returning to our notes, that was a lot of information about Jared to write down. I don't want you to write down that whole paragraph. Here's the basics. Here is what you need to know. The room is 12 feet by 15 feet. The walls are 9 feet high. There are 2 windows that are 6 feet by 5 feet. There's 2 doors that are 30 inches by 6 feet. There's 1 gallon of paint and it covers 350 square feet. But how many gallons of paint will it be to put 2 coats of paint on the walls? So keep that in mind. We're not trying to paint the doors. We're not painting the floor or the ceiling either. And we're certainly not going to paint the windows. So how much paint am I going to need to put 2 coats on? Hopefully reading it like that and knowing what to write down will help you understand the situation a little bit better. Again, make sure that you do have this written in your notes. Pause it if you need extra time, but I'm going to move on. As I visualize this, I actually created a 3D model. Here's my room. You can see that I've got some windows here. You can turn it and you can see I've got a door. On the other side, I've got another door. So I have created this 3D model. Now, it's really hard to draw a 3D model. So instead of you drawing a 3D model, why don't I flatten this model? And let's draw the flattened version of that model. It should look something like this. Wall with a couple of windows, a wall with nothing on it, a wall with a door, and a wall with another door. Now your model might look a little bit different and that's okay. The problem didn't tell us exactly where the windows were or exactly where the doors are. But the nice thing about this problem is it doesn't matter where they are. We can just put them anywhere and it's not going to change our answer. Draw your diagram, and then once your diagram is drawn, we can start labeling it. Like, we know that this wall would have to be 15 feet, and this wall would have to be 12 feet. Because it tells us that the room, that would be this right here, the room is 15 by 12. So I've listed 15 by 12. The next thing that we know is that the walls are 9 feet high. So again, look at my model that I've drawn. This wall is 9 feet high. But what happens when I flatten this out? That 9 feet high becomes these edges here. So that means I know that this is 9 feet and this is 9 feet. Notice the symbol that I'm using. I'm using the symbol for feet instead of the abbreviation FT. I will be using FT later, but this is another handy symbol for us lazy mathematicians. Now, each one of these are 9 feet, so we can go ahead and label each one of those if you'd like to. And this is 15 feet, so that means that the wall across from it is also going to be 15 feet. This is 12 feet, so the wall across is also going to be 12 feet. Now, again, we need to remember that we're not going to be painting the windows. We're not going to be painting the doors. So even though paint's going to go everywhere else, we don't need to worry about those pieces. So it's probably a good idea to know how big they are so we know we don't have to worry about them. We'll start with the windows. It says that the windows are 6 feet by 5 feet. And later on it tells us 1 gallon of paint covers about 350 square feet. This square feet is a hint that we're going to need to find the area. We'll need to find the area that we paint, but we also need to figure out the area that we don't paint. So the window is 6 feet by 5 feet, remembering that area is equal to length times width for our rectangles. Then we know that the area of each the area of each window is going to be 6 feet times 5 feet, which is equal to 30 feet squared. I'm going to go ahead and label those as well. These are 30 feet squared. Now let's move on to the doors, and you're going to notice with the doors we have a little bit of a challenge because we're dealing with inches and feet. We can't mix units like that. It sets us up for some problems. So I'm going to change the inches to feet. See if you can do that in your head. 30 inches, and knowing that there's 12 inches in a foot, that means that 30 inches is equal to 2.5 feet. Now that I know that this 30 inches can be replaced with 2.5 feet, Now I'm going to find the area of the doors. The area is again equal to 6 times, now it's 2.5. And 6 times 2.5 is equal to 15 feet squared. So I know the area of each of the doors, and I remember that I'm not going to be painting those doors. This was 15 feet squared, and this was 15 feet squared. So I know the areas that I'm not going to paint. Now we need to find the areas that I am going to paint. We have 9 by 12 here. A 9 by 12, again, we're just finding the area, so that's going to be 9 times 12, which is equal to, quick calculations here using my calculator, 108, but it's not just 108, it's 108 square feet, or feet squared. And this wall is 108 feet squared, which means the wall across from it is also going to be 108 feet squared, with the exception of the doorway, which we can subtract that out. Now let's find the other walls. Remember, this is 15 feet. Our height of our walls is 9 feet. So again, in order to find the area, that's going to be 9 times 15, our length times our width. And 9 times 15, with some quick calculations, is 135 feet squared, which means that this wall up here is also going to be 135 feet squared. Think about all of the areas that we need to paint. Let's get all of the walls up there. We have 108, that takes care of this wall. We have this wall, which is also 108. However, we're not painting that doorway. So let's make sure we remember to subtract that out. 108, subtract 15. Let's take a look at the next one. This is 135 feet. So 135, however, we're not going to be painting the doorway, so we need to make sure we remember to subtract that out. And 135 feet here as well, 135 square feet, but we're not painting either of those windows, so subtract 30, subtract 30, that takes care of that wall. 1, 2, 3, 4 walls, and now we can just plug that into a calculator. Make sure you have a really good calculator, plug that in, and see what you get. I hope you took the time to plug that into your calculator. And when you did, I hope your calculator agrees with mine that it's 396 square feet. So we're done with the problem, right? Not quite. That's where the perseverance comes in. It's where the make sense of problems comes in too. The question is asking us how many gallons of paint to put 2 coats of paint on the wall. This just tells us the square footage. It doesn't tell us how many gallons of paint we need. So this is just going to be for 1 coat of paint, but remember it's asking for 2 coats of paint. So we're going to take that 396 square feet and we want to multiply it by 2. And that is going to give us 792 square feet of paint needed. So we need 792 square feet of paint, and if we reread, we are reminded that 1 gallon of paint covers about 350 square feet. You can do this a couple of different ways. Maybe you want to say, okay, let's use 1 gallon. Let's subtract out 350 square feet. That's going to use up 1 gallon. That means we still have 442 square feet that we need to paint. So we're definitely going to need another gallon. Now, of course, there are other ways of doing this, but I'm just trying to go with the most basic ways. And this still isn't going to leave us with the whole thing painted. We still have 92 feet squared that we still need to cover. So I'm going to need 1 more gallon. And that 1 gallon will for sure take care of those 92 feet squared. Let's count up all of those gallons. Looks like we need 1, 2, 3 gallons. And yes, there will be some left over, and that's okay. It's better to have too much than not enough. So 3 gallons will be needed. We're not done yet. We're done with the problem finally, but we're not done with the lesson. Remember, our structure is we're going to use an example, and then after the example, it is time to reflect. So it's time to reflect. I want you to think about how you can make sense of problems. What did we do in this particular problem? We looked around the room, tried envisioning painting the walls. We had a 3D model. We had a picture or a diagram. We went step by step. What was the thing that was the most helpful to you? Maybe you can make a goal about that. You can start off your goal or your reflection by I can make sense of problems by doing what? You have to figure that out. Part of your reflection needs to include how you can make sense of problems, but it also needs to include how you can persevere in solving problems. What did we do to persevere? Well, we reread the problem a couple times to make sure that we were actually answering the question. We went step by step. We started by finding the areas of the places we weren't going to paint. Then we found the areas of the places we were going to paint. Then we read it again and realized, hey, we need to figure out how many coats of paint and double that. So we went step by step. Maybe that's a good way that you can persevere. Maybe you can persevere by really understanding what the question is asking and making sure you work all the way to the end to answer that question. You have to fill out these on your own. What is your reflection? What is your goal? How are you going to make sense of problems? How are you going to persevere in solving them? Ladies and gentlemen, that's it for today. That is Math Practice 1, how good mathematicians do math. Good mathematicians make sense of problems and persevere in solving them. Have a great day. We'll see you next time.